Okay, good evening, everyone. Rohit Pawar this side from Shape My Skills. I hope you all are well and healthy. As you know, we started Industrial Conclave for industrial expertise to promote the industrial academic collaboration for the development of more constructive ideas. Shape My Skill has taken a step forward by the means of Industrial Conclave 1.0, where every day at 4 p.m. an industrial expert will be giving webinars on new technologies daily. We're having a Bentley team today, and they will guide you about STAAD and its applications. Without further ado, let me introduce Ms. Apurva Bidkar. She is working as an associate program manager in Bentley system. Over to you, Apurva ma'am.
Thank you, Rohit. Welcome everyone to the session of Industrial Conclave 1.0 STAAD Pro and its application. We thank you everyone for taking out time and attending this session. Now, I would like Mr. Vineet Mehta, who is the Senior Programs Manager of Training Partners at Bentley, to share a few words. Over to you, Vineet.
Thanks, Apurva. Good afternoon, everyone. The world has changed a lot in the last 20 years, especially when it comes to building the infrastructure. Hence, to keep up with the current pace, digital infrastructure has become an important part of the engineering. Bentley has been supporting the professional needs for creating and managing the world's infrastructure, including buildings, roadways, bridges for 30 plus years now. Bentley has solutions for the entire life cycle of infrastructure asset tailored to the need of various professions, which comprised of integrated applications and services built on an open platform. For structural engineers, STAAD Pro has been one of the most used applications for years now. As most of you know that STAAD Pro is a comprehensive and integrated element analysis and design application that includes visualization capabilities and a wider range of product or design codes. One can analyze any structure exposed to various load, including static, dynamic, wind, earthquake, thermal, and moving loads. STAAD Pro provides structure analysis and design for any type of project, including buildings, plants, bridges, stadiums, and marine structures. So without any further delay, I hand over the stage to Apurva to take this session ahead. And on behalf of the entire Bentley team, I thank you all for taking your time for this session today. Over to you, Apurva.
Thank you, Vineet, for sharing the importance of digital infrastructure in today's world. So this session will be delivered by Richard Tully, who is the Principal Technical Support Engineer and has completed 20 years at Bentley. Richard is a member of Institute of Civil Engineers and Institute of Technical Structural Engineers in the United Kingdom. And he has a vast experience in promoting the structural products like STAAD, RAM, MS Towers, etc. So without any further delay, now I would like to hand over the mic to Richard. I'm sure this session would be exciting and informative to all of us. Thank you, and over to you, Richard.
Thank you. So today, this session, we're looking at certain aspects of structural enterprise workflow. And if I just open that up a moment, so you can have a look at what we're looking at. So let me just pull this over here. And so the first thing we're going to look at is STAAD Pro Physical Modeler. And the idea here is that we're trying to model structures as they're constructed on site. With the analytical modeler, you tend to model members between node points. So we're trying to get away from that, move away from that, and model the structures as they are constructed on site. So let me just open up or start a model in STAAD Pro. So I'm going to start a new file. I'm going to build a model from scratch, a concrete structure, and show you some of the features of the STAAD Pro Physical Modeler. So I'm going to create a new file, and I'll just call this, say, RC Physical Modeler 1, Let's give it a name. So it's going to be a physical model. The units are metric, so I'm going to create that. So that takes us straight into STAAD Pro Physical Modeler, which is what we've got here. So the first thing I'm going to do to generate my model is set out a grid. So up at the top, we've got the option for grid, create a grid. So I'm going to open that one up. So we've got a default metric grid. So the plane, if I just pull that to the side, is going to be the XZ. So I'm going to change the plane to XZ. So the number of grids in the X direction. So spaces, I'm going to put in 20 in the X direction at 1 meter spacing, and in the Z direction, I'm going to put in 10. So I can click on OK, and that will generate the grid. So that's a good start. So let me try that one again. So grid, XZ, so coordinate system, sorry, world coordinate system, and click on OK. So that gives me the grid. So I'm going to change the view. So I'm going to view from the top. So we've got that here. I can also enter a user-defined coordinate system. So up at the top here, I've got UCS. If I double click on that one, and I'm going to select the origin as, say, minus 10 meters in the X direction. Put that in as 0 and click on OK. So that sets that here. I want to actually relocate that to the midpoint of the grid, and I can do that by going to, let me see, the spreadsheet, and if I go to the grid, so change this one here to UCS 1. So that relocates the origin of my user-defined coordinate system. So the next thing I want to do here, I want to add effectively what would be similar to a plate element in the analytical modeler. So we're using surface elements. Surface elements are more flexible than the plate elements in the analytical modeler. So I'm going to add a plate. So if I go to the surface element and click from point to point, come up here, go along to this point, down 4, along 4, up here. And so we can define a slab like that. The next thing I want to do, I want to change, just now the slab is sitting at 0 height, and I want to raise that slab 4 meters. So that's the next thing I'm going to do. And again, I can do that if I go to the spreadsheet, go to the nodes. Just now you can see the Y level is set as 0. So I'm going to select all the members. This is another interesting or new or a very good feature in the STAAD Pro Physical Modeler. So if I go to the Y coordinates, select all of them, and if I right click, and we have this feature here, we've got a cell calculator. And here we can you can either add, or you have plus or minus to add or remove or reduce dimensions. You've got times, division, equals, percentage. So you've got a lot of flexibility with this cell calculator. So I'm going to put in a value of 4 and add that. So you can see the value now is 4 for the Y value. And if I change to the 3D view, so here we can see the slab is now 4 meters above ground level. And that's where I want to start from. The next thing I want to do, I want to add some walls. So again, I'm going to change the view. I'm going to change to top view. And if I zoom in here, I want to select the nodes. So I'm going to select this node here, hold down the control key, select this node, this one, and this one. So I'm going to select those 4 nodes, and I want to copy them and I want to paste them. Or another way of doing that, if I go to the model, I can use translational repeat. So it's going to be in the Y direction. Number of copies is going to be 1. Spacing is going to be -4 because I want to drop them. And I'm going to click on OK. You do have an option to preview the action before you actually commit to it. But I'm just going to click on OK here. So if I change back to the 3D view, you can see we've got the nodes down at this point here. So I want to select the nodes only. So if I right click I can go to selected objects only, and I can highlight them. So what I want to do now is just add some wall elements. So again, I'm going to use the surface option and click on here to add some walls, and do the same around here. So we could have a lift shaft in here. So I'm just going to generate the walls for that. So we can enter that. We could also have some door openings in here. So I'm going to add an opening in this part of the wall. And before I do that, I'm just going to check the coordinates of this point here. So we can see it's -2, 0, 4. So I'm going to generate another user coordinate system. And the origin for that is going to be -2, 0, and 4. So click on OK. And I'm going to generate a grid at that point. So I'm going to use my user-defined coordinate system 2. The plane is going to be the XY. And the coordinates, number of spaces in the X direction, I want 4 at 1 meter. And in the Y direction, I want 4 at 1 meter. So if I click on OK, so that generates a grid. So if I select that, again, right click and go to selected objects. So I'm only looking at this one panel here. And I'm going to put in an opening. So I can click from this point here to this point, to that point, to here, and back to the origin. So we can put an opening in the wall like that. So once I've done that, I'll just switch everything back on again. So we have the floor slab, we've got the walls, and we've got the opening. So just let me come out of that and just highlight everything. So again, I can look at that. So what I want to do now is just copy that. So I want to create a number of stories. So I'm going to use translational repeat. I'm going to translate in the Y direction. Number of copies, I'm going to put in 10. The spacing, again, I'll just keep that at 4 meters. And this time, if I just move that to the side here, we've got the option to preview the action before we commit to it. So if I click on preview, then this is what we get. So that's what I'm looking for. So I'm just going to click on OK. So I've got the model coming up like that. So the next thing I want to do is just add some columns. So I'm going to add some nodal points at the base level. And I can do that by going to the coordinates here. So I'm just going to scroll to the bottom. And I'm going to add some additional node points. So I'm going to add 8 of them. Sorry, 10 of them. So the first 6, I'm going to start off with an X coordinate of, well, first of all, -9, then 9, then come down to -9 again, come down to 9, -9, 9. So that's 1, 2, 3, 4, 5, 6. Then I'm going to add some additional ones. So -2, let's come down here. That should be -2, then 2, -2, and 2. So I'm just going to put in some additional values here. So it's going to be at ground level. So the Y value is going to be 0. And let's put in the Z value. So I'm going to have 2 at 1. Then I'm going to have 2 at 9. And then come down here, I'm going to have 4 at 5. And then the last 2 at 9. So we can see them down at this lower level here. So I've got 3, 6, 7, 8, 9, 10. So I want to select them and copy them. So I'm going to select those 3. Hold down and shift the control key, select these ones over here, and so zoom in here. So again, I'm just going to right click, selected objects only. and select. So yeah, we come in here. So if I just select all of them, so we've just got the node points as shown here. I'm just going to switch. If I go to, let's come down to, right, so I want to copy them. And again, I want to use the translational repeat, so I want to put them at the upper level. So I need the coordinates at the upper level. So let me just switch that back on again, selected objects, just to see all of them. I'm going to select a node up at the upper level. So we can see the upper level is at 48 meters. So let me go back down to this lower level and select those nodes again. So 3 here, hold the control key down. I've got 3 here, I've got 2 here. And if I just come over here, and I've got 1 here and 1 over here. So I'm going to go to translational repeat. So I want 1 copy, and the offset is 42 meters. And I'm just going to preview that. No, it wasn't. So 46, was it? Nope, 48. So preview that. Yep, so we've got them up there. And so you can preview that before you commit to the action and then click on OK. So we have the nodes at the bottom selected, we have the nodes at the top selected. So I'm going to add some columns. So to do that, I can just go to the nodes tab, and I can go to member generation in the Y direction, so we can generate our columns as shown here. So again, another interesting feature with the program is if you have, let's say we have the slabs, we have the slab edges varying as you go up the building. So it could be bowed. We can represent that quite easily using the software. So if I come in here, and what I want to do now is just select the external nodes. So I'm going to select the external nodes along here, hold down the control key and select the external nodes along here. So again, right click, selected objects only. So I can select them. And what I want to do now is just change these. So I want to extend them, say by a value of 1.05. So I'm going to multiply the length and increase it by 5%. So I can select all the nodes up here. So I've got all the nodes here, so I can select all of them. And it's the X direction I want to change. So I can select that, right click, go to the cell calculator, put in a value of 1.05. And I can multiply the existing values by that. Let's do that again. Come down here, select these values here, right click, cell calculator. Let me just take that out and put it again. And should multiply. Try again one more time. There it goes. So it's now 10.05. So what I want to do now is take these node points, take selected objects, and do the same with them. So take those values, cell calculator, and increase them by 5%. Then I want to take these ones in here, do the same thing, and take those values and increase them by 5%. So the cell calculator, and then take these intermediate ones here. Look at the selected objects only. and then cell calculator, increase them. So just keep doing that as we work up the building, and then increase these ones. And finally, this one here, right click, selected objects only, and take those nodes and increase them. So once we've done that, we can look at the whole model again. So we can see we can get this bulging effect. So it's very easy to obtain this now with STAAD Pro Physical Modeler. It's easy to put in openings with STAAD Pro Physical Modeler, and it's easy to adjust the openings if you have to do that, and we'll look at that shortly. So the next thing I want to do here, just before I complete this exercise, is I want to assign member properties to the slab, to the columns. So I'm going to select. So I can select all the surfaces. So I can right click, go down to surfaces, and select all of them. So I can go to the surface tab up at the top. So as soon as you select either a node, then you'll get a node tab appearing at the top, and it'll give you all the properties you can use to change the node information, similarly for members or for surfaces. Here we're selecting surfaces. So I'm going to select that. I'm going to assign a material. So I'm going to select concrete, and I'm going to assign that to all the surface members. Next, I'll assign a thickness. Let's say 0.3. In fact, let's make it 0.25. So I can change that. If I go to view, I'm just going to switch off the materials there. So what I could do if I wanted, I could just select the walls. I could select the wall elements, and I could give them a different thickness if I wanted. So if I come to, let's look at the model in plan, and come in here, see if I can. And let's look at that in. Okay, I'll take one. Let's take the. I'm going to take the walls along one side only. So I'm going to select those walls. Again, one thing you could do to make this a lot easier is if I select all these walls here and come down to the bottom, then what I can do here, if I go to surface, I can give it an attribute. I can call that wall 1. So that will make it easier to select the walls. And I'll just do the same here. I can make that wall 2. So again, I can go to attributes and call that wall. So that becomes wall 2. So an example of that, if I want to select that, then I can select a wall, then right click and select by description, and it will select all the other elements for that wall. So if I want to give that a different thickness, then I can go to surface, thickness, and I could make that 0.3. So you can change the thickness for members like that. So the next thing I want to do, I want to assign properties to the columns. So I'm going to select a column. In fact, if I go to, let me select, where are we? Yeah, if I right click, just select anywhere, right click and go down to members. And if I go to special selection, then I can easily select the columns by select parallel to Y. So I can select all the columns. So the columns extend the full height of the building. You can break the columns at intermediate levels. So if you wanted a column lift to go up 3 stories, then you can have a break at the 3rd story. So that's a lot easier, again, to assign in the STAAD Pro Physical Modeler than it would be in the Analytical Modeler. I'm going to work with what we've got here. So again, if I go to Member tab, I can go to Section. And here I'm going to put in a prismatic section. And I'm going to put in a rectangular section. And for convenience, I'm just going to make the section standard. So 0.6 by 0.6 of a meter. And get the program to calculate the values. And I can call that a 600 by 600 column. So click on OK. So that will assign the section. Again, I've got to assign the material. So it's concrete and click on OK. So let me go back into that section a moment. Yeah, I'll just change that to concrete. Right, so we've got the columns assigned, we've got a section size, and we've got all the properties. So the whole idea here is just to try and show you how easy it is to model structures using the STAAD Pro Physical Modeler. I would probably recommend using that to build up your model. I find it's a lot easier than assigning a model in the Analytical Modeler. As I said, it's far more flexible when it comes to things like openings in slabs. And again, let's just have a look at that. So if I go to the front view, and let's pick on, say, the slab here. So I'm going to select that. Again, right click, selected objects only. And let's look at that in 3D here. So again, let's put in a user-defined section in here. So if I just select that node here, so I'll just take a note of the coordinates there. And I'm going to define a new user coordinate grid. So the X coordinate is going to be, in fact, let me cancel that a moment and select this one here. Okay, so I'll use that one and come in here. So I'll use that as the origin. So the X value is minus 13.401. The Y value is 24. And the Z value is 0. So I'm going to click on OK. And then go to the grid. So this is going to be 3. Again, the plane is going to be the XZ. So the number of spaces in the X direction, I'm going to go 20 and 10 in, let's change that, XZ. So in the X direction, we've got 20, the 1 meter, and Z direction, so I'll click on OK there. So we now have the grid appearing up here. So select that. And if I just zoom in here, if I want to add an opening, so let's go to Polygon Opening, and let's put in something in here. So you can put an opening in here, and I'll put a circular opening and just pop that in here. So we've added some openings at that level. Again, right click, so we can now show the whole structure now. So what I want to do now, I want to transfer this into the analytical model. Before I do that, let me just go to the View tab up at the top, and we can see what the analysis model will look like. So the program is generating the finite elements. Switch off some of these items. So we can zoom in here, we can see the layout of the finite elements. So I'll just switch off the analysis model. I'll transfer this model into the analytical modeler. Before we do that, again, one of the things we can do, if I go to loading, you can automatically set up combinations. So it's similar to what you can do in the analytical modeler. You can select from any of the codes shown here, and if you've defined loadings on the members, then you can set up load combinations in here. It's going to cancel that. And you can also set up your analysis commands. So if I click on here, you can select from the options here. So you can have a elastic analysis, linear elastic. You can do a p-delta analysis, a direct analysis, buckling analysis, and geometric nonlinear analysis. So I'll just select linear elastic and click on OK. So if we transfer the model back to the analytical modeling, so it's just take a few seconds just to do this. Okay, so that opens up the model in the Analytical Modeler. If I right click, go to 3D rendering. So we have the model here. If we zoom in here. So here we can see the openings which we generated. We've got a rectangular opening and we've got a circular opening. So if at any point the client comes back and says, I want to change these openings, I want to move this one or increase the size of this one, within the Analytical Modeler, that is quite difficult to do. You'd have to remove the finite elements and regenerate them. But with the STAAD Pro Physical Modeler, that's an easy action to perform. So if we go back into the Physical Modeler, I'm just going to do this with one of them. So again, if I just change the model, again, I'm just going to select this slab here. And again, look at the selected objects only. Go to 3D view, so I can select that opening. And here I've got the option to move that opening if I want. And I'm going to move it, say, in the X direction, say 0.5 meter, and in the Z direction, if I wanted to, I can move it -1. And again, you've got the option to preview the action. So you can see the new location of the opening. You could click on OK. So moving an opening is very easy within the STAAD Pro Physical Modeler. So modeling in general, I would say, is easier within the STAAD Pro Physical Modeler. So that was just an exercise in modeling. Let me have a look at some additional tools for adding sections and show you how to add some loadings. So I'm just going to minimize that one and let's come up and look at. So this is another model created within the STAAD Pro Physical Modeler. We're seeing it in the Analytical Modeler. So I want to go into the Physical Modeler, transfer it back, and here we have the member here. So I just want to show how you can easily add some properties. So if I click on here, I want to add, first of all, some supports. So the approach to adding supports is slightly different to what you do in the Analytical Modeler, because normally you define the support first and then you'd apply it to the model. It's the reverse in STAAD Pro Physical Modeler. You select the nodes and then you assign the support. So again, just hold down the Control key and I'm going to select some nodes. I can select those nodes. The node tab appears up at the top here, so I can select that. And you've got some options here: fixed, pinned, custom supports. So I'm going to select fixed and add them. So next thing I want to do is select the columns or the vertical members. So I can right click, go down to members, special selection, and I want to select the members parallel to Y. So that selects all the columns. And again, I'm going to go to member attribute and select that as a column. So I'm going to do the same with some of the beams. So select this beam here. So I want the beams in the X direction. So again, I'm going to go to members, special selection. And I want the members in the X direction. So I'll click on OK. So that'll define all those members. And again, go to attributes and call that a beam. Now I'll define all the members in the Z direction. So again, right click, special selection. So I'm going into members, special selection. And this time we're looking for the members in the Z direction. So that would define all those members. So again, I'm going to go to attributes, again, give it beam, and that would define those beams. This is a bit like groups in the Analytical Modeler. So it makes it easier to select members and assign sizes to them and also material properties to them. So next I've got the inclined braces. So again, I can select one of them, come down to members, special selection, and this time I'm going to select sloping. So that will select all these brace members. And again, back up to attributes, and I'll select them as a brace. And then we've also got some horizontal bracing shown here. So again, I'm going to right click here, select by description, which will select all of these brace members. And again, go to attributes and define them as braces. So once we've done that, the next thing to do is assign properties. So we'll start with the column. So all we have to do is select one vertical member. We can then right click, select by description. That will select all the columns, and we can then go up and assign a section. So here I'm going to select standard section. I'm going to select for the database the data structural, and I'm going to assign a square hollow section. So I'm going to select the top one here. So 250 by 250 by 10, and OK that. So the next thing I can also do, I can also assign the material. So I've come down to steel, and I'm going to select grade 355 for these square hollow sections. So click on OK. Next, we'll come to a beam. Select a beam, then right click. I can select by description. That will select all the beams. And again, I'm going to go up to section. This time I'm going to change to, for example, the British sections. I'm going to select universal beams and just come down and select a section, say a 457, let's say 178 by 67. So I'm going to click on OK. And I'll do the same for the beams in other directions. So select that beam, right click, select by description, come up to section, and again, I'll just select a section here. So let's say a 356, 171 by say 67. So I'm going to select both of them. So beams in the X and the Z direction. And again, I'm going to select by description. That will select all the beams and go to member and assign the material. So I'm going to select steel 275 and click on OK. Let's come over to the horizontal bracing. I'll select that and again select by description. So come up to the section here. And so what I want to do here is just change to an angle. And I'm going to select a 200 section, so say 200 by 16 and assign that. And again, I want to select the material. So I'll use 275 and let's come down here. No, catalog, I want to select model and 275 and OK that. So what we've got left is we've got the braces. So if I select that again, right click, I want to select all the braces. So select by description, assign a section. So I'm going to go for a prismatic. So select a prismatic section description. So that's shown as feet. So let me just cancel that. That's because if I go to file and go to options, I just want to change that from English to metric and click on OK. So again, I'll go to section. Here I'm going for prismatic. So again, I'll call that a 75mm rod. And so the dimension is going to be 0.075. Dimension is going to be 0.075. And we have all the properties. I'm going to click on OK. So I'm going to put that in. The grade of steel, I'm going to material. Again, you could make it 275. You could even use American grade of steel if you want. So it can either be from one country or another. So you can mix and match different materials. So I'll just go with 275 and select that. So we've now got all the steel sections assigned. We want to assign some properties for the surfaces. So the first one, I want to put in a 12.5mm plate, steel plate. So again, you get the surface tab appearing up at the top. So I'll assign a material. Again, 275, I'll assign that. And a thickness. So I'm going to go for 0.0125, so 12.5mm. And finally, we've got the material over here. So it's a map foundation. So again, I'll select the material. So I'm going to go for the database and change concrete. So I can select that and click on OK. That's a nuisance. So if I come in here, let's just save that. And let's do that one again. So if I go for material, so select concrete, let's see, catalog, steel. So I'll just go for that, click on here. And the thickness, I want to put in as say 450, so 0.45 of a meter, and assign that in here. So we've now defined all the materials. So we can assign some properties to some of these. The braces, for example, I want to make them tension only. So I can select one of the braces, right click, and go to select by description. So if you go to the members here, and I want to assign these as, so the axial behavior, I can select tension only member. So this is for the braces. And let's just switch off some of the information we're looking at, the materials and the sections. So if we zoom in here, so we get the tension only braces shown. So you can see the graphics are a lot more impressive than you get with the analytical modeler as well. And the next thing I want to look at is if we come over here, we select a section, zoom in here, and I want to show some properties in here. Right click. In fact, if we want to go to 3D view, so I want to try and rotate that a moment. Let's come out there a moment and zoom back in here. So we've got the angles, and I want to rotate those angles so we have the flange at the top rather than at the bottom. So I can select one of them, right click, select by description, which will select all the angles. I can then go up to the member, and I can use the rotate command. I'm going to rotate them 180 degrees. So that flips the angles around, gives me what I'm looking for. The other thing, when you're modeling, again, everything is modeled based on the center line. So I want to change that. So if I come out here, I want to select the beams in both directions. So if I select that beam and then right click, select by description, and that will select all these beams. Again, I can go to the member tab up the top, and I want to change the cross section position. So if I select that, so I want the top of the beams coming in at the same level. So I can select top center. So we've got a number of options here for modifying the location of the members. Here I'm going to select top center, click on OK. And what that does, when I zoom in here, the top level of the beams line up. So if they're different sizes, the top flanges line up. That's what we're looking for. We've got a problem over here with the columns. You can see everything is still framing into the center line of the members. So I want to change that. And how we do that, if I just right click anywhere, we select all the members framing into the columns. So if I hold down the control key and just go around the perimeter. So let's come down here. And I want to rotate the model a moment. So I get this beam over here and this one here. So we've got all the beams which are framing into the columns, all the beams around the perimeter. So again, I've got to the members tab up the top here, and I'm going to select the axial end offset. Click on that one. And then again, if I zoom in here, you'll see the beams now frame in to the face of the column members rather than framing into the center line. So again, that's a nice neat trick within the STAAD Pro Physical Modeler. So we assign properties, fixities to the columns. We've also got a map foundation here, so I'm going to assign some foundation information to that. So I'll just switch off go to view, 3D view, and just select that map foundation. So I can go to the surface and I can apply a map foundation up here. Click on that option, put in subgrade modulus. I'll go with the value input here. And you've got an option here for the actual behavior, as I'm going to assign compression only, and click on OK. So it defines the foundations to all the members in the model. So the next thing is to assign some loading. So very quickly, let's get that done. If we go to loading, I'm going to create some load groups. The program already defines a load group 1, so I'm going to go in with load group 2. Load group 1 will be for dead load. So load group 2, I'm going to define that as live loading. And again, I'll just copy that and paste that in here. And just select that as live. Create another one. And I'll call that wind loading. And that will be in the X direction. And again, I'll just copy that and paste this in here and select wind. And I'll do another one just for wind in Z direction. So again, just copy that and paste that in here and select wind. So we can now assign some loads to the members. So if we go to loading, we'll select load group 1, which is effectively dead load. So I'm going to come in here, and if I go to the loading, I can apply a self weight. So I'm going to click on that one, so that'll count for the self weight of the structure. If we go to load group 2, live loading, and let's put some live loading on, say, this structure here. So again, I'm going to change the view, change the side view, and I'm going to select the members in the structure here. Right click, I'm going to view those selected objects only. And I want to assign the members to these members here. So again, right click, select by description, and that will select those members. I can right click and view only those members if I want. So if I select one of the members, it brings up the member tab up the top here, and here where I can assign the loading. So again, I just want to select by description. It will select all of them. I'm going to put a distributed load on the members. So it's a live loading, uniform, the global Y direction, and I'll use the value of -3 and click on OK. So that will assign the loading on here. So again, I can just show back to the original model. I can copy that if I want to add that to the dead load. So I can go to, if I go back to loading, and I can add the loading. Let's select my dead load. I can say add loads. So I'm going to add the loads from the live loading and click on OK. So that pulls in the live load values into the dead load. So I can copy it from load to load. So the only thing here is I might want to change the values in here. So if I go to the spreadsheet and I can go to the loadings. So the member loads, and I want to look at the distributed loads here. And if I just scroll along here, so the values are shown as -3. So what I can do in here, let's see if I can, cell calculator, I want to put in a value of -1.5. So that's just, sorry, that's adding that. So I want to take that off again. So that's 1.5. I can do the same over here, right click, go to the cell calculator, and I'm going to reduce that value by 1.5. So just say minus. So we can change the values. We change the values. We imported the loads from the live load as 3 kilonewtons per meter, pulled it into the dead load and changed the value from 3 down to 1.5. I'll also add a surface load to this element here. So select the surface. Again, I can go to the surface parameter up the top, and I can select uniform pressure, and I'll go with the default here, value of 0.5, and click on here. So that's added to the dead load, so I can add that. Let me just select one of the wind loads. So the wind loading in the X direction. And let me change the view. And I want to select the members at this upper level here. And again, right click, selected objects only, and look at the members here. So we've got all the members here. So I want to go to the node command, and I'm going to add a nodal load. So this is wind load in the X direction. So I'll put in a value of, say, 20 kilonewtons, and I can click on OK. So that will assign a nodal load. So right click there. Node value, I want to take that off 0. Change that. So you can apply the loading in the values shown here. So let's do the Z direction. Same thing again, go to node, nodal loads. So in the Z direction, put a value of 20, X direction 0, and click on OK. So we can apply a nodal load and right click. Let's let me switch off. So go to view just now and come to loading. I'm just going to switch off the load just now. I want to look at adding a panel load to these members here before we're almost ready to finish here. So if I look at the view from the top, again, I'm just going to select these members, right click, go to selected objects. So that isolates only those members. Now if I go to the model tab up at the top, and I want to add a panel loading. So click on panel. And here I'm just going to select from node to node to node. So I can add a panel. Just work my way around here. We can add panels. So I've added some panels here. I'm just going to complete this. The one thing to note here is when I'm going from node, first node to the second node, then that's edge 1, second node to the next one, that's the second edge. Going from here to here, that's the third edge. And then when I complete that, that's the fourth edge. That's going to be important in a moment and when I discuss the next stage. So edge 1, 2, 3, and 4. So just quickly run through these other ones. Okay, so we'll add the panels. So that then introduces this tab up at the top panel. I'm going to assign a distributed load over the panel. And again, I'll just go with this default value of -2. It's going to be in the global Y direction. I can select where I want to assign that. I'll just go for live loading and click on OK. So here we assign that. I can get the program to now distribute that loading. So if I look at the model in 3D, we can see the load is distributed in 2 directions. But what if you wanted to distribute it in 1 direction for some panels? How do you do that? So if we go again, go to the spreadsheet, and if we go to the panels, come up here, here it defines that all edges are fixed. So if I want to define that as one-way spanning, so the top edge I want to make free, and the third edge I want to make free. So I can select edge 1 and I can fill the column with that value, edge 3, fill the column with that value. And then if I regenerate, if I go back to the panel and redistribute the pressure, we can now get a one-way spanning panel if you want. So here it's spanning side to side. You can have it spanning in the opposite direction if you want. So you have the option to span the loading any way you want. You have complete control over distributing the load to panels. So I'm just going to go back to the selected objects and show everything. So again, that's just another feature of showing how you can apply loading in the STAAD Pro Physical Modeler. And again, as I mentioned earlier on, you can if you go to loading, you can assign your load combinations. You can assign your analysis command from this drop down here, so that when you go into the analytical modeler, it's already assigned. So what I want to do now is just take this model into the analytical modeler. So if we go back to modeling, go to analytical command, analytical modeling, click on yes. Try that again. I'm just going to close that a moment. It should still go in. Yeah, so here we go, pulls in here. The one thing to note when you come in here, hasn't pulled in the sections, but the section properties, when it pulls it in, you cannot change them in the analytical modeler. Everything you've assigned in the STAAD Pro physical modeler, then you cannot change those values in the analytical modeling. So if you set your supports, then you can't change them in the analytical modeler. If you set your sections, you can't change them in the analytical modeler. If you set your loading, it cannot be changed in the analytical modeler. So if you have to make any changes, you then have to go back into the physical modeler to make those changes. So you can revise the model then. There is one other way of getting around that. And one thing you can do, you can go to utilities and you can drop the physical model. So if you do that, you can then make the changes in the analytical modeler. The downside of that is you then cannot go back to the physical modeler to change the model in any way. You've broken that link, so you have to make any changes within the analytical modeler. So you do have that option of dropping the physical model if you want. So one last thing I want to show you on the physical modeler, if I just create a new file, just going to close that. So this is something which has just recently been added with the latest update. So if I click on new, and let's just call this WT1. So physical model, metric, create. And what I want to show you now is, again, a feature which has been added, and this is Structure Wizard. And this allows you to generate a water tank. So if you're involved in the analysis design of water tanks, then you can model them in STAAD Pro Physical Modeler now. So you can set the number of compartments to, if you want, or if you want 3, you can set that up. So I'll change it back to 2. The base thickness, you can put that in. The total length. If I come in here, I can show the the dimensions. So we can get the overall size of the tank, 12 meters by 8 by 4.5. So that's shown here. The outer wall thickness, the separator wall thickness can be defined in here. I've got some columns shown in here, so we can set the size of them. Again, if you just scroll down here, the supports, it can be a soil or it can be piles. So I'll just change that back to soil. Again, scroll down here. So you can put the stiffnesses in here, the loading. So to include the self-weight, the compartment, you can put the height of the water in the compartments. So if I want that one to be 2 meters, then you can define that. So you can define all the properties for the water tank. So I'll just save that. Come down here. So compartment 1 shows you the height of the water. Compartment 2, again, you can get the height of the water. So I can take that template, preview it in STAAD Pro and just click on OK. So you can then pull that into STAAD Pro. The next stage would be if you've got some, if it's a buried tank, then you can apply a lateral soil pressure. You can do that within STAAD Pro Physical Modeler. You can also apply, you can assign a roof to this, a concrete roof, if you want it covered. That can be done in Structural Wizard. If you want to assign, say, a metal roof to it, then that has to be done within STAAD Pro Physical Modeler. So you can generate your model, you can apply any additional loads, you can then transfer that through to STAAD Pro Analytical Modeler, and then take it into advanced concrete design to analyze and design the reinforcement for the water tank. So this is a new feature which has been added to STAAD Pro with a new release of STAAD Pro. So again, anyone that's involved in water tank design, then this is an essential feature which I recommend you look at. Thank you.
Thank you, Richard. We will take a break of 5 minutes and then we'll resume. Thank you.
Hi, everyone. Hope you all are back. So I would now request again Mr. Richard to take over the session for continuing the second part. Thank you.
Thank you. I'm now going to look at this model here, and we're going to look at steel autodrafter. Before we begin by looking at this, one thing I want to mention, just see if I can just close that a moment. I'll open it again in a moment. Right, looking at the screen here, if you look at the bottom right-hand corner, primary licenses, and we've got structural select entitlements. That's quite important because steel autodrafter is a structural select entitlement. So what that means is, while any company that has a current maintenance agreement with Bentley can use this part of the software, if you stop your maintenance agreement, then you can no longer use steel autodrafter. So far it's the only program which is a structural select entitlement. So just be aware of that. So you can only use this while you have this structural select entitlement, while you currently have a maintenance agreement with Bentley. So if we go into the model, which I had previously. So here we have lots of members in here. Again, if I go to a 3D rendering, so we can see the lower section is concrete. We've got steel above that. We've got bracing in the roof. I've got some bracing at the sides. So a number of elements in here. So I'm just going to close that. So the first thing I want to do is analyze the model. So I've got a current analysis for it. Okay, close that. That's done. So we can now go into steel autodrafter. So steel autodrafter allows us to draw elevations, plans, etc., showing the steelwork. Give you more. It gives you a good overview of the steelwork you're using in the software. So you'll get the sections, you'll get the bill of materials, etc. You'll get a takeoff. So this is the sort of information you can get from that. So if we go through the tabs up at the top, first one I've got is grids. So here we get the grids in the X direction and in the Z direction, and elevation markers. So you can see the program automatically assigns grids. If I close that first of all, it automatically assigns grids at the column locations. So by default, it will put a grid at every column position. The program also allows you to define a grid at any other position. For example, where this beam frames into this column here, the program will allow you to switch on a grid at that location. Similarly here, here, again here. So everywhere you have a member framing in to an elevation, the program will set up a grid which you can switch on or off. So again, if I go back up to grids, and that's what all these other values would be for. If I just switch two of them on, give that a mark, just call that AA, and I did something like that, and if I clicked on OK, then it would define the grids shown down here, which would correspond to some of these values up here. So I'm just going to switch those values off. So by default, you get a grid at every column position, but anywhere there's a vertical piece of steel on the perimeter, then the program will set up a possible grid at that location. So you can then go in and switch that grid position on or off. So that gives you the grids. So again, I go back into that. That gives you the grids in the X direction. In the Z direction, you see it's given numbers 1, 2, 3, etc. And again, these values are located at the column positions. And again, with any vertical members, let's close that. If you have any vertical members, center here, for example, then the program will allow you to add a grid position to represent where that vertical member is. You can also set up drawing groups. We'll do that shortly for the members. Next, we come into the drawing style manager. So your layers, center lines, grids, dimensions, labels, etc. You can change the name if you want. If you want to change that to something more meaningful, then you can come in and do that. Likewise, you can change the color to something more meaningful. Then that can be defined in here. So you can set up defaults and you can import them if you have already set up a file. So if you upgrade and you need to import these styles, that can be done using this option in here. And similarly, if you have all your defaults set up, you can export a file which you can then pass on to other colleagues to use within the company. So at some point, if you need to restore back to STAAD Pro's or Steel Autodrafter's values, you can do that here. And again, you can set the current value, you can set that to current default value. So similarly for member labels, so for a steel column, you can reference that as a column to column beam with moment connection. So again, you can change these references if you want. So these are the default values. You can come in and change them to suit your particular requirement. And again, for any reports, then you can set up all the font information in here, text size, etc. That can all be defined in here. So the drawing unit, you can define that as metric or English. So my default is metric. So you can switch on the node numbers, the member numbers, member properties. So here we have all the American sections being defined in this model. So I'm going to go with that. The grid can be switched off or on. Once you create drawings, you can see a list of the drawings created in this dialog box. So we haven't done that yet, so we'll come back to that one. You can get the material takeoff. So the material takeoff for each of the sections, you get the length and the weight as shown here. So let's go back to the layout and how to generate drawings. Generating drawings is actually fairly simple. So you can, for example, just select a member, right click, and you can draw a section in the X direction or in the Z direction. So if you want to draw one in the X direction, select a scale. You have a number of scales here you can select from. You can select a full section or a part section. I'm going to go for full. You can either draw that or you can add that to your drawing list. So I can add that in here if I want. Again, I'll just select that and I'm going to draw a section in the Z direction this time. Again, full section, and I'm going to add that to my drawing list. So you do have the option of just generating the drawing from scratch, or you can add it to a drawing list as I've done here. So once you've done that, I can then draw the sections. So I'm going to come down here and I'm going to select draw. So I've created two drawings. So one in the X direction, which is drawing one, and one in the Z direction. So elevation grid one shown here. So a couple of things I want you to note here. If I go back to drawing one, I want to go up to roof level. So the program as it stands is not picking up the rafter up here, and I'll explain why it's not doing that in a moment. And similarly for drawing two, when we come to look at the bracing, you'll see the bracing is shown as 4 individual members. So that might not necessarily be what you want. You might want the bracing to be just 2 members, one extending from the top left-hand corner down to the bottom right, and another one going from the top right-hand corner down to the bottom left-hand side. So you might want to show them as 2 members rather than 4. So you can do that within the program. But looking at the drawings in general, so you have the schedule of materials. You've got the material takeoff shown here, and you have a legend shown here. So this is, in some respects, typical of the drawings you can get from Steel Autodrafter. So let's try and fix a couple of the things we're looking at here. So in drawing 1, I'm going to regenerate that shortly, and we'll actually have the proper rafter element shown in here. So if I go back to the layout, so the problem we have here, when I look at that, is because the program is pulling in information from STAAD Pro Analytical Modeler, then each member is a separate member. And what we want to try and do is define that as one continuous member here. So that's the next thing we're going to do. So if I right click here, draw cut section, and that takes us into this dialog box here. And I'm going to look at the top chord and click on this icon up here. And if I click on the members in here, and what I want to do, I want to select all the members forming that rafter. So I can select them all. I can right click. I can create a group. So I'm grouping all the members together. So the purlin selection, you can select from any of the standard databases. Again, I'll just come down and select, say, British. You can put in an angle or a channel. I'll just go for, say, an angle, and I'll put in 100 by 100 by 8. Click on there. And I'll do the same over at this side. So hold down the Control key and select all the members forming the rafter. Once I've done that, right click, create a group, same thing again. So select British, angle, and again, I'll select 100 by 100 by 8 and click on OK. So here we have the sections shown here. So I'm just going to close that. So what I should now be able to do, if I click on that member, I'm going to draw a section, and I want to draw that in the Z direction. So I'm just going to draw that straight away rather than adding to the drawing list. Wrong side, so let me try that again. Yeah, so if I zoom in up the top here, so you can see we now get the full rafter showing here because we've grouped the members together. And we can do the same for the bracing. So instead of having individual bracing members, we can group them together just to show one braced member. So again, if we go to the layout, and let's try that over here. So if we cut the section along here, so this time I want to look at cross bracing. So I'm going to select that member and that member. So I'm in bracing. So select that member, that one. I'm going to create a group. And similarly here and here, create a group. And just work my way down through the bracing members. So when we now create the elevation, these members should now be showing as just 2 members rather than 1, 2, 3, 4. So if I close that and click on here, and I want to draw a section. So that is the XY. Let's see that again. Yeah. So if we zoom in here, that's just showing as one section. That's just showing as one section rather than 4 individual members, which we had previously. So I think that was, we had 4 individual members. So now we can show that as members. So the program gives you the option to group members together. So rather than showing the individual elements. So again, because you're pulling the model in from the analytical model, then the members are noted as going from node to node to node. So you can overcome that by creating a group. So again, you can go to your drawing list, which we had previously generated here, and you can draw all your members. So it's a very quick, simple way for generating drawings. Again, you can just pick on a member, right click, select that member, and you can draw a section. So you can draw as a section. Again, you just need to group the rafter members up here. So you can very quickly get all your sections. So you can get your schedule, you can get your material takeoff, and you can get your legend. So you can go back here. We've got the drawings. We've got the material takeoff. Again, you can view your drawing list. So we can get the material takeoff, and the text form is shown here. So it's a way to obtain your elevations and drawings information. You could do this for both steel and concrete. It's mainly for steel, developed for steel, but you could also use it if you wanted simplified concrete elevations or sections. So let me go back to the model again and just draw one last one. So if I click on here, I can right click and I want to draw a plan at that level. Again, I'll just draw that. I'll add it to the, no, I'll just draw it. So here you can get a plan on that particular floor level with all the sections shown. So once you've done that, you could export that to any CAD. Here we've got the option to open in MicroStation, but it can be exported to any CAD package. So as I said, Steel Auto Drafter is a structural entitlement. So you can only use this particular module if you have a current maintenance contract with Bentley. Okay, so that's all I want to cover with Steel Auto Drafter. Thank you, everyone.
Thank you, Richard, for the wonderful session. I'm sure all the participants must have learned many things on STAAD Pro Physical Modeler and Steel Auto Drafter. Thank you very much. Now, I would like to invite Manish Modotia, who is the Senior Programs Manager of Training Partners at Bentley Systems, to give some words about aspiring engineers. Over to you, Manish.
Thank you, Apurva. I'll share my screen. Let me know once it is visible to you.
It's visible, Manish.
Right. Wait a second. Let me just move on to the presentation. Sorry. Okay. So to begin with, let's talk about today's infrastructure scenario and what is the requirement of the world in terms of infrastructure that is needed to support the population and everything else. So what is the estimate that we are making for different infrastructures to be created, like ports, rail, water infrastructure, or telecom? What is that amount that is being invested? So 3.3 trillion is the estimate that we will be spending annually through 2030. So and that is the distribution. Most of it would be going into power, but then you would see how it is divided and what is the status that we would gradually see overcoming. So Indian infrastructure spending is close to $400 million per day. So if you see, that is the requirement that is coming out in terms of the current scenario of infrastructure that we have. And why so? What is that calculation that we have come up for? So in next 5 years, what is that we are planning to invest in terms of what we have, be it road infrastructure or uh, the smart cities that the government is planning to invest on, and the fourth largest railway system that we have in the world. So this is the distribution. Though you must have heard of problems that we face every other day. These days it's rainy season, and you must have heard of water clogging and everything all around. So these are some of the biggest challenges that we face in our country. To overcome this is the amount of money that we are going to invest in, and those are all engineers that who will have to work on these things. So now the interesting part is the productivity of this investment is very, very low in terms of when compared to manufacturing or IT or anything else. The construction industry, the productivity of construction industry remains very low. Why is it so? It's because of the overruns that we have in terms of cost, in terms of budgeting, in terms of schedule, in terms of resources. So everything affects us, and that's why we need like we mentioned in the beginning, that we need more and more digital and more sophisticated systems to have capping on what we are doing, how we are doing, and all those things. So you can see why construction matters to the world economy. It is as I mentioned, 13% of world's GDP, and the annual productivity is only 1%. That is something that we need to change. So what do we need is 1.6 trillion. You can estimate the value of this amount of money. We are talking of becoming the fifth largest economy, 5 trillion, but still we have to see where to invest the money and where to come up and how we can increase that. And that would all be, as I said, in the hands of engineers. But you would be surprised to know that most of you who are engineering graduates would agree to the scenario that we have currently. How many engineering graduates we have every year, and how many of you get placed. So that is the scenario that is very different from what we see. And in terms of the industry requirements, we have to see where we are going, how we are headed. And these engineers, if you do the right training, if you get into the right mode, learn right technology, upgrade yourself from the beginning, you can be far more better tomorrow than you are today. And that is where we have training partners like Shape My Skill, supporting engineers, day-to-day engineers who aspire to be engineers tomorrow, to learn the right technology and become employable. I'll just quickly show you what we have in terms of our product portfolio. This is what we have in terms of our products and basically the infrastructure. So what all you can see in the city or around a city, whether it is visible or invisible, we have a whole lot of products to support that, whether it is related to rail, whether it is related to communication, whether it is related to power services, whether it is related to buildings. So all whole lot of product portfolio. More than 300 products is what we have currently in our portfolio. And on top of that, we have all of this into a digital platform as well. So you can interact and interoperable technology. You can work on and take things into different products and technologies and share and make changes wherever it is needed. That is how probably we are looking to help engineers, so that you can probably take on the world tomorrow. And I wish Shape My Skills also would be involved in this part. They are already doing good stuff, and I hope you will be taking advantage of what all good work we are doing along with Shape My Skills. So advancing infrastructure does not mean just to build something and let it be there. It has to be a coordination between the economy and the environment. And we, the people, the professions, you, the engineers, are basically involved in this, who have to take care of this. And that's wherein we as Bentley Institute come in, as I said. So evolving, supporting you all, supporting professions who are involved in this decision making of what sort of economic growth we want, and what is the balance that we have to make with the environment today. So that's what we are looking at basically. So that's all from my side. Thank you very much for your time, and I appreciate you joining this.
Thank you,
So
Manish, for sharing the insights on Indian infrastructure and the possible productivity opportunities in construction business. I'm sure this session would be very helpful for you all. And I would like to thank on behalf of Bentley Systems to all the participants who have joined the session. And I wish you a great day ahead. And over to you, Shape My Skills team.
Hello. That was a wonderful session. I want to thank you, everyone from Team Bentley. That is Vineet Mehta, Richard Tully, Manish Madotia, and Apurva Bidkar for making this happen. Your willingness to share your time and expertise was critical to the success of this event. We were fortunate to have a wide range of speakers from all arenas. It is our collective efforts and thoughts on best practice that bring us closer. I hope this collaboration between Bentley Institute and Shape My Skills lasts on. Thank you so much. So